Hello class, this is Mr. Boovie. We are going to take a look at example 2 in lesson 1-1. And again, this is not in your student companion. However, there is some additional space for notes between pages 1 and 2 if you'd like to write anything down. Those of you who would rather just watch this, listen to it, understand it, take a few moments to go through it, and then you're going to work on the try it for example 2 on page 2 in the white packet. All right, so here we go. We have a car starting a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas left in the tank to the number of miles the car has traveled. X is the miles, and y would be the gallons. So today we're going to talk about x and y intercepts. They want to know what they are and what they represent in this problem. All right, so for any function in the world, the x-intercept is always of the form, the coordinates would be something, comma, 0. So it's the point on the x-axis down here in red, where the graph, which is here in green, where the graph crosses that red line. So for this problem, it looks like 320. So at the point 320, the x-intercept is 0. Y-intercept. The y-intercept for any graph will always be of the form 0, comma, some y value. So for this one, we want to think about when we're at 0 on the x-axis, where does the green line hit the blue y-axis? So when x is 0, what's y? And it looks like 0, comma, 16. So the x-intercept is in red, 320, comma, 0, and the y-intercept is in blue, 0, comma, 16. We're not quite done because it wants to know what they represent in this situation. So after 0 miles, we have 16 gallons of gas. So that's going to be right when you left the gas station, you haven't gone anywhere, you have a full tank of gas, 16 gallons. All right? For the red one, let's see, as you're going along here, you're driving, you're running out of gas because you're going farther and farther. Once you get to 320 miles, you ran out of gas. You have 0 gallons left, so that's what it represents in this problem. Okay, so I will take a minute here to erase the board, and we'll take a look at part B. Here we go. That was fast. Part B, what are the x and y intercepts of the graph y equals the absolute value of x minus 3. If you don't remember, these bars are the absolute value. And for any x value that you plug inside these bars, it's going to return the positive value. So the absolute value of 8 is 8. The absolute value of negative 8 is 8. The absolute value of negative 3 is positive 3. The absolute value of 0 is 0. All right, so it returns a positive value, and then we're going to subtract 3. Why don't we go ahead and pop this into our graphing calculator. Okay, so I'm going to go back to y equals. We're going to clear out the x squared minus 3 from the last problem I had in there. And we're going to go ahead and pull up the absolute value. And one way to get there is using the math button. Go right to the number menu, option 1, where it says ABS. That'll pull up our absolute value bars. We could talk about other ways to get there tomorrow, but let's go ahead with that one for now. So it was math, number 1, absolute value. Go ahead and hit the X button, arrow out to the right. Now enter subtract 3. All right? If you have a standard window using Zoom 6, you can just hit graph. If the last thing you did was on a standard window, you don't have to hit Zoom 6 again. You could just hit graph. On our standard window, we see that the function is a v. just like that problem we did 2 videos ago where we had the diver. We have an absolute value, goes downward, reaches a minimum right here, goes back up, looks like it hits an x-intercept there and another x-intercept there. So I would say that my x-intercepts, there are 2 of them. One is at -3, 0. The other is at +3, 0. And the y-intercept right here is at 0, -3. Let's double check. Right here, let's check the solution. Get rid of all this ink. They solved for the x and y intercepts using algebra instead of using the graph. You can see here that they set y equal to 0 and they solved for x. That's how they found their x-intercepts, also known as the zeros of the function, because those are the numbers you put in for x that are going to make y equal 0. And we have the y-intercept at the bottom. For the y-intercept, algebraically, you plug in 0 for x, and then you solve for y, -3. So it looks like they agree with us from our graph. -3 and +3 are the x-intercepts, and -3, 0, -3 is the y-intercept. That concludes example 2. What I'd like you to do now is do something similar for the try it on page 2, and we will go over that tomorrow.